Welcome to ECE 3270 Lecture 11. So today is going to be a little bit different regarding what we're going to cover in the lecture. So rather than introducing a new technique or material or concept, I want to show you how some of the concepts that we've learned are typically applied in a lot of industrial machinery. So we've seen lots of industrial connection videos along the semester. We've seen a lot of applications. And what we see on the HMI right here is a simulation of an actual industrial application. So what's going on behind the scenes in this simulation is there's logic that simulates the functionality of pneumatic cylinders. And there's a pneumatic cylinder that controls the vertical position of this box and a pneumatic cylinder that controls the horizontal position of this box. The way that pneumatic cylinders work, as we've seen in the connections videos, is that you'll have a switch at either end of the cylinder, and when it is fully retracted, that sensor will be on, and that sensor means that the cylinder is retracted. And then when it is fully extended, there'll be a sensor that designates that the cylinder is fully extended. Likewise, for our horizontal cylinder that controls our horizontal position, there'll be a sensor at the extended position and a sensor at the retracted position. So using these two cylinders and the four sensors, we can know exactly where our box is in this transfer system. Now right now, we can tell by this green outline that we are currently in manual. So we can currently manually control this cylinder. So the top two buttons, the raise transfer and the transfer lowered, so this one's telling us that we've already lowered it, so we don't need to lower it again. But this is the raise transfer button, this is the lower transfer button. So this controls our vertical position, and this is the extend and the retract, which controls the horizontal position. So I can press this button and the box will raise. And I have to hold it, and there's a delay because air cylinders take some amount of time to shuttle. It's not instantaneous. So we don't get the feedback right away because we haven't made the sensor yet. So we press and hold, and then in a moment, we see that we have reached our destination. Okay. So this is something that we covered in Lab 2. This was a very simple application where we had to write a bit latch sequence to be able to control the position of this box based off the button Start Transfer. Now, it would be fairly straightforward to replace the bit latch sequence with a state machine. That's not what I'm demonstrating. That's not what I'm showing. What we're demonstrating is a mix of methods. So in most of the labs that you've done, you have either used state machines or sequential logic in the form of a bit latch sequence. But in reality, in large-scale machinery, you wouldn't simply use one technique or the other. As we've discussed, these are both tools in the toolbox that you should learn how to appropriately apply. So one of the ways that these are applied is by allowing a machine to have a hierarchical control methodology. So rather than just having the machine controlled by this Start Auto button all the time and these manual buttons all the time, we can choose. Do we want the machine to be controlled manually, or would we like the machine to be controlled in an automatic fashion? That's what I mean by a hierarchical control structure. So we can choose what mode the machine is in. Is it in a manual mode, or is it in an auto mode? So right now, we're in a manual mode. And while we're in manual mode, we can press the Start Auto Transfer button, press and hold it, it's not going to do anything. And if we were to shift into auto mode and attempted to use the raise transfer button, the extend transfer button, or any of that, it's not going to work because we're no longer in the appropriate mode. We're no longer in manual mode, so our manual buttons don't work. Now, if we were to use our Start Auto Transfer, since we are in auto mode, if we press this button, the box will automatically transfer over to the truck and then return back. And if we were to press manual, now we could go back to manually controlling the position of this box. So in the code, what this usually looks like is at the top, we're controlling our mode using a state machine. So if we're in state 1 would be manual. So we default to manual mode. So if we're wind up in an error state where our state is 0 or less than 0 or greater than 2, we're going to default to manual. And then if we're in manual, the state that is manual mode, and someone presses the auto button, we will shift into auto mode, which is state 2. And if we're in state 2 and someone presses manual, we will go back to state 1, which is the manual mode. So we have a state machine with default state and transition logic, and we also have an output, or in some cases multiple outputs, from this state machine. So if we're in manual mode, then we're going to tell our cylinders to enable manual control. And that's how we are able to disable these buttons when we're not in manual mode. Because if we're not in manual mode, so we're not in state 1, then our output, manual enable, is false. And when manual enable is false, our buttons controlling the position of the box manually will do nothing. But if we change modes into manual, now we're in state 1, and therefore our output, manual enable, is true. We can again use our manual control buttons. Okay. So we have a state machine that controls the mode of operation. Is this machine going to be controlled manually by an operator, or is it going to be under its own control based on some sequential control program that we've written? So this, like I said, is how many machines in the industrial world are controlled today. At the top level, you have a state machine that allows you to control how the machine works. Is it in manual or is it in auto? And there may be even more complex than that. A lot of times you have many modes of operation, not just simply manual and auto. And if you're in manual, then you should have the option to move all of the motions on the machine manually. And if you're in auto, then there should be some program that controls the machine. And here's our program that controls the machine when we're in auto. So rather than saying we're only using state machines or we're only using a bit latch sequence, we used a state machine where it was appropriate, where it's driven off of user interaction. It's not a sequence. We don't know what they're going to press. We don't know what the next decision is going to be, so we don't have a way of knowing what the next mode should be. So rather, we use a state machine to be sensitive to the decisions of the user and let it be input driven rather than sequentially driven. But on the other hand, we know that in auto mode, we always want this box to do the same thing. We want it to go up, over, down, and then retract. So it wouldn't make as much sense to use a state machine, though you could, to control the box in its position in an automatic fashion, because we can do something simpler. We can use a simple bit latch sequence to control the automatic function of this machine, but at a mode level, it's not sequential. So we need to split those two components of the program apart and use the state machine to control the mode, and then use the bit latch sequence to control the automatic operation. So in our bit latch sequence, rather than just having a start signal, we look for the start signal, and then we ensure that we're in the proper mode. So we're looking to see that we're not in manual mode. Another way that we could have done this just as easily would be to check that we're in the proper state. So check to see that our state is state 2. So right now, we are in manual, but when we go to auto, our state will be state 2. And so when this start transfer button is pressed, we will begin our auto sequence. And the program progresses in an automatic fashion and moves the box over to the truck and then back. And we could do it again. And we could do it as many times as we wanted, because we're still in auto mode. So to be able to accomplish the dynamic, complex performance that modern industrial machines are expected to be able to perform, you need to be able to understand multiple different techniques of programming. We need all of the tools that we've looked at. We need Boolean logic, we need multi-scan logic, we need sequential logic, and then we also need input-driven logic. And then to accomplish this higher level of functionality, we have to appropriately mix those techniques with proper documentation. So here we have the components of the machine that are input driven, which is the mode control driven off of a state machine. We have the sequential auto sequence driven off of a bit latch sequence. And we have documentation explaining what the groups of rungs do.